Hey guys, Mr. Verga here, coming at you straight from Mathland. I hope everybody's having a great day. Today we're going to talk about some special lines that we can draw inside of triangles. So I'm on page 29 looking at the warm-up for today on task 1.5. And if you'll look with me at number 5 on your warm-up, it asks you to construct the three medians of this triangle ABC. So in order to do that, the first thing we have to understand is, what is a median, right? A median simply is a special line that comes from a vertex and bisects the opposite side. So in our triangle, if a median comes from a vertex, then how many medians does it have? Yeah, it's got 3, right? One from here, and one from here. Now, I could go about trying to construct this with my straight edge and compass. Nah, that's not the point of today. Today we're just gonna get really close, so we can go ahead and use our ruler and we're gonna go ahead and measure, okay? We're gonna go ahead and measure our side lengths and then put the midpoint on each of our sides, because remember, we have to cut each one of these sides in half with our median. So this side right here is right at 4 3/4 inches. So if I put that in half, you can use a calculator. 4 3/4 or 4.75 divided by 2 is 2.375. Now, where is 2.375 on my ruler? Well, there's 1 inch, there's 2 inches. 2.5 is right in the middle of 2 and 3, so 2.25 is right in the middle of that. So 2.375 is going to be right up here. And it's okay to estimate it a little bit. So there's the midpoint of this line segment AB. And I'm just going to repeat that process for all 3 of my lines. So this guy right here is right at 5.5 inches. So I'm going to go to 2.25-ish. Well, $2.75 rather, I apologize. 2.75, about right there. Okay, and finally, my line here, that's longer. It's about 6.5, right? So to cut that in half, I need to put a mark at about 3.25. And it's a little bit over, so I'm gonna put it about right there. And again, you can estimate a little bit and we'll be just fine. So now I've got the 3 midpoints of my triangle drawn. Now, a median comes out of a vertex and bisects the opposite side. So now that I've got the midpoints of each one of these, I know where the line needs to go to cut it in half. So all I've got to do now is take my straight edge and draw a line from a vertex. So I'm going to start with this vertex up here, and it needs to go through the midpoint of the opposite side so that it cuts it in half. And there we go. That's one of the medians of this triangle. So I'm going to repeat the process. I'm going to start at this vertex over here, go through the opposite side at the midpoint, and finally, my last median through the last vertex, from the vertex to the midpoint, and there are my 3 medians. And we'll see that my 3 medians intersect right here in the middle. Well, is there anything special about that point of intersection of the medians? Yeah, definitely. We'll talk about that a little bit later. But for right now, those are the 3 medians of this triangle. Now, are there any other lines that I could construct? Definitely. Take a look at number 6. It says to construct the 3 perpendicular bisectors of triangle ABC. So if I grab another triangle, all right, and we've already defined a median. From a vertex bisects the opposite side. What is a perpendicular bisector? Well, it's exactly what it sounds like, right? A line that's perpendicular to a side and cuts in half, which means it goes through the midpoint, right? So again, if a perpendicular bisector is perpendicular to a side, then how many do I have? Yeah, 3. I've got one that goes through this side, one through this one, and one through this one. And to construct them is very similar at first. I'm going to take my ruler and use it to measure my sides and mark the midpoint. So that guy's pretty close to 5 inches, so 2.5 is right in the middle. This guy right here is pretty close to 5.25 inches. All right, so a little over 2.5. Again, you don't have to be super perfect here. We're just getting close. And this guy is at 5.5 inches, and 5.5 then divided by 2 is going to be 2.75, so 2.75 inches be right here. Okay, so I've got the midpoints of my 3 sides of my triangle, and now I need to construct a line that's through each midpoint and perpendicular. Perpendicular, so I need to grab my handy dandy protractor. I need to make a line that's perpendicular through this point. So I'm going to put the center of my protractor right on that midpoint, line up the sides with my 0 here on the bottom, and then make a mark at 90 degrees, just like that. And so now when I construct this line, notice how it's not going to go through a vertex. That's okay. This is now perpendicular, and it has cut this side in half. So that is a perpendicular bisector. So if I follow the same procedure for each of the other 2 lines, right? Center of my protractor right on that midpoint, mark it 90 degrees, and then let's draw my line. And again, notice how this is not necessarily going to go through a vertex, and that's okay. And then finally, last one, just like this. You'll notice that I should intersect with the other 2. That's a good sign that you're doing it right. And voila. All 3 of these constructed lines are perpendicular to the sides and intersect at one point. And yeah, that point of intersection is pretty special. We'll talk about that later again. Finally, the third and final thing that it asks you to construct in this activity, it says to construct the angle bisectors. Now this one's a little bit trickier, but it's not too bad. So let's get another triangle. And when I do this one, I'm going to use a triangle that's been cut out already. You don't have to, but feel free. Because I want to show you guys one way to construct an angle bisector, right? Let's say I want to bisect this angle right here. That means cut it in half. It should make sense to you guys that I could fold this angle in half. And then when I open it, the crease here has bisected the angle. Pretty cool, huh? The other thing you could do, of course, is measure it with a protractor. If I'm trying to measure this angle now down here, I need to put the center of my protractor on the vertex, line one side up with the 0, and then the other leg will tell me that this is a 72-degree angle. And so all I have to do then is divide that in half. 72 divided by 2, of course, is 36. So if I go and make a mark at 36 degrees, I will have bisected this angle. Just like that. Pretty cool, huh? You can double check yourself by folding this angle in half so that the two sides touch each other. And check that out. We were spot on. Pretty cool. Finally, I'll do the protractor one more time. Center of your protractor right at the vertex. Line one side of the angle up with the 0. Find the measurement from the other side. Read carefully. This is 40, 45, 46, 47 degrees. So if I wanted to bisect it, I need a 23.5 degree angle. So 20, 1, 2, 3.5. And then of course, all I've got to do is draw my line from the vertex through there. And I've got my angle bisector. Now, I'm going to highlight this angle bisector that we found earlier by folding the angle. And of